Let's say you are asked to integrate 2x times cos of x squared plus 5 dx. Now for now you should have been able to do this pretty easily, so simply you set this to be equal to u, and this we have is du over dx times, so to 2x times dx would be equal to du, and this would get it to cos of u du if we set u is equal to x squared plus 5. So integrating this would be easy because this is obviously sine of u. So this is equal to sine of u. So that is, simply the integral involving the trigonometrical function. Now there are more complicated ones. Let's say you're asked to integrate this function, so cos cube x. So you're asked to integrate cos cube of x. Now cos cube of x, now this is equal, so cos cube of x, so this is integrate of cos of x times cos square of x dx. And we have known that cos square of x is equal to 1 minus sine square of x. So this is equal to cos x times 1 minus sine square of x dx. So this is equal to integrate of cos of x minus cos of x sine of square of x dx. Now cos of x, now the integral of cos of x is easy. So this is the integral of this is sine of x. But what we really want to see is this. So we want to integrate the most pressing task here is actually to integrate this cos of x sine square of x dx. So here now we don't, because in these parentheses it is only x, and the point is we need to find a u that somehow allows us to integrate this. So usually in the trigonometrical function you do not always set u is to be, say, a polynomial, but in this case you can actually set u to be sine of x. Why? Because du over dx is cos of x. So that du is cos of x times dx. So for that we can get rid of this cos x and dx, and all we are left with is sine square x, which is u square. And so here we can get this to sine square of x du, which is u squared du. Integrating this would be easy. And so the point here I'm trying to say is that sometimes in trigonometrical function it is not always obvious what u would be, but the point we need to do is we need to use multiple trigonometrical function and use trigonometry identities to put it in a form that we can solve. And that is simply how you try different ways to solve it using the trigonometry identity that you are given in the formula list. So it is not always that you will be clear, and the point in many of these is how you combine the knowledge of different chapter and work your way through your question.